Okay, so picking up where we left off on Thursday, complex number can be written in multiple forms. One way is Cartesian, one way is polar, and one way is Euler form. Find the modulus and argument for each complex number and rewrite in polar and Euler form. You can do this one, that'll be easy. We will do B and C. So we need to know the modulus and the argument. Well, the modulus is equal to R is equal to square root of 1 squared plus negative 1 squared equals square root of 2. And to find out the theta, let's find out how to do that. Make your imaginary versus real plane. We are going out 1 and down negative 1. Vector is right here. And if you want to set this up, you can look at this as a triangle and say you're trying to find theta. Well, we went down negative 1, we went right 1, and we have a length of square root of 2. So you have multiple ways you can do this. I might choose to do this as sine inverse of negative 1 over square root of 2. And that is sine inverse negative square root of 2 over 2 if you rationalize the denominator. And that is negative pi over 4, which is also equal to 7 pi over 4. So you have multiple ways to write your answer, multiple ways to find it. I found that theta is negative pi over 4. No reason why I shouldn't use that one. So if I want to write it in polar form, then I have z is equal to r square root of 2 cis theta, which is negative pi over 4. And that's square root of 2 cosine negative pi over 4 plus square root of 2 I sine of negative pi over 4. And you could obviously simplify it and get back to your Cartesian form. And if you want to do an Euler form, well, that's an easy one. R e I to the e to the power of I theta. Z is equal to R e I theta square root of 2 e negative pi I divided by 4, and there's Euler form. If you want to do C, well, let's find out what the modulus is. Let's see, square root, if we square this, we get 4 times 3, so that's 12, plus, if we square this, we get 4, square root of 16, and that is equal to 4. If we want to find theta, we are going on the real axis, 2 roots of 3. And on the imaginary axis, we're going up 2. So our vector looks like this. And if we want to find theta, we again set up a right triangle. And I think the easiest numbers to work with are 2 and 4, and that is the opposite and hypotenuse. So I'm going to use sine again. Theta is equal to sine inverse. Opposite is 2. Hypotenuse is 4. Sine inverse of 1/2. And you think, what angle, when I take the sine of it, gives me a y value of 1/2? Well, that is, let's see, pi over 6. So your theta is pi over 6. Just using the unit circle, we were able to find that out. So if I want to rewrite this in polar and Euler form, I get 4 CIS of, what was it again, pi over 6. And in Euler form, I get 4e to the power of pi over 6 times I. Okay, so A should not be a problem now that you've done B and C. A couple other things we have to do is rewrite. We're given maybe polar or Euler form, and we have to go back to Cartesian form. And so let's try it with this one. Rewrite each complex number in Cartesian form. Just expand this. Cosine pi over 4 plus 8i sine pi over 4. 8 square root of 2 over 2 plus 8i square root of 2 over 2. 4 root 2 plus 4 root 2i. And there you go. Cartesian form. Same thing here. Expand it. Square root of 2 cosine negative 45 plus square root of 2i sine 45 negative 45. And that is, let's see, square root of 2 times square root of 2 over 2 plus, the y value here is negative, because if you remember the unit circle, right, that's how we're doing this. X value is positive square root of 2 over 2, y value is negative square root of 2 over 2. So you get 2 over 2 minus 2 over 2i, or 1 minus 1i. And if you'll notice, b here is the same thing as b here, and it should be the same, square root of 2 CIS negative pi over 4, square root of 2 CIS negative pi over 4. Yep, we're good. Okay, so now we're going to multiply and divide while we're in polar form, and then talk about properties of arguments, and that'll be it. So if we do that, multiplying and dividing in polar form, that's what we're doing. And we have here, if you take the complex number in polar form and the argument is a sum, you can write it as a product of two polar form complex numbers, inputs being the two components of the sum. If you have the difference in an input, you can write it as the quotient of two complex numbers in polar form. If you have some, I guess, identity, you might call it, 2 pi times k, so that just means you're going around the circle however many times from A. Well, that's the same thing as taking the polar form version of just A, because, again, it will not change. You just went around 2 pi times, maybe some number, 10 times. Maybe you went around 10 times, you still end up back here. And that one, these all have names: product rule, quotient rule, and identity rule. Product rule. Product between two polar form complex numbers can be written as the polar form complex number of the sum of the inputs, or the arguments. So this is CIS, pi over 5 plus 3 pi over 10, convert to same denominator, and you will get CIS. Let's see, that's 2 pi over 10, so that's 5 pi over 10, and that's CIS. Let's see, pi over 2. Boom, done. Simplified. Quotient of two complex numbers in polar form, so I'm going to write it as the difference between their arguments. CIS of pi over 5, or 2 pi over 10, minus 3 pi over 10, and that is equal to CIS negative 2 pi over 10. Nope. Mistake. It's 2 pi over 10 minus 3 pi over 10, so it's negative pi over 10. And you can leave it there because that's polar form. 107 pi over 6. Now, this one you have to think about for a second. If you look back up here, this does not apply, this does not apply if you look at them, and this is the only one that would apply. So, this we want to think about as being 107 pi over 6. That means you went around a whole bunch of times, and then you stopped, maybe let's say here. Alright, we want to say, what is this equal to if we simplify it? So we're going to go back in time and say, where did we start from? So blue would be A, and we're trying to find out what that A is. Well, so on this one, you can use your calculator. You want to say 107 pi, we're looking for some number A, that is equal to 107 pi divided by 6 minus 2 pi would be 12 pi over 6. So we want to minus off some 12 pi over 6, some multiple of that. And you ask yourself, how many times does 12 go into 107? Well, 12, 24, 40, 36, 48, 60, 72, 84, 96, 96, so that's 8. So, what's the remainder when we do this? 96 pi over 6 subtracted from 107 is 11 pi over 6. This number, 11 pi over 6, is less than or equal to 2 pi. So that means that we're good. This is the first number that we can use. So this is our A. So A is equal to 11 pi over 6. So if we simplified, we said CIS 107 pi over 6 is equal to CIS 11 pi over 6. And you're done. Okay, last thing we want to do today is look at properties of arguments. Properties of arguments, product property. Product of an argument is equal to the sum of the components that you were multiplying. Quotient of an argument is equal to the difference of the respective components. If you have some complex number raised to some power n and you want to know the argument of it, that's equal to n times the argument of the complex number. So quotient rule, and this one is power rule. Those are all related to logarithm rules that you learned a long time ago. If z equals square root of 2 cosine I sine theta, find the modulus and argument of this product, w times z. So write it out. This is 1 minus I times square root of 2 cosine theta plus square root of 2 I sine theta. Now you want to have these in the same form, so we are trying to find the modulus and the argument. So I suppose it would help me to convert this one to polar form. I want to convert this one to polar form. Let's find out what that is. Well, the modulus of this one is easy to find. R is equal to square root of 2 because you have 1 squared plus negative 1 squared. Take the square root of that, you get square root of 2. Find theta. I think we already did that earlier. 1 minus I. 1 minus I. Yep, right here. So the argument is negative pi over 4. So that means I can rewrite this one as square root of 2 CIS negative pi over 4. And we're multiplying it by square root of 2 CIS theta. Well, I have the product of two complex numbers in polar form. I want to know the argument of them. Argument of a product of two complex numbers is equal to the sum of their arguments. And so that would mean this is equal to, let's see, 2 CIS negative pi over 4 plus theta. So that means modulus, which is what we're trying to find, our modulus for WZ is equal to 2. That was this number. And our theta, or argument, WZ is equal to negative pi over 4 plus theta. So that was fine. So let's try one more together. Let's do this one. W is equal to 2. Z is equal to square root of 2. CIS theta. So if I want to rewrite in polar form for W, let's see, well, I have that already, that my R is equal to 2 for W, and theta for W. Let's see, if it got rid of sine and it got rid of cosine, then let's see, what angle would that be? It got rid of sine, so that means it must be pi over 2. Pi over 2. Think about it for a second, if you're not sure where that pi over 2 came from. It's a real number, 2. And let's see. Nope. Incorrect. Use your visual, right? Here's your complex number, and let's see, the angle we have there is 0. 0. So, there's that. Now, we can answer our question. For WZ, the modulus of WZ is just 2 times square root of 2, 2 square root 2, argument, WZ, is equal to the sum of their arguments, so theta and 0, so it's just theta, and we're done with that one. Last one we should do, and we'll use a picture to make sure there's no mistakes on this one. Let's look at W. W is equal to I. Cosine is gone, and I have a vector here, 1 on the imaginary axis. So that means my theta is pi over 2. And let's see. For W, R is equal to square root of 1, which is just 1. And we just found theta to be, for the argument, shouldn't be using theta. Argument of w is equal to pi over 2. And we have wz is equal to I times square root of 2 cis theta. So that means modulus wz is equal to, well, modulus of this one is just 1. 1 times the modulus of that one just gives me square root of 2. So modulus of wz is square root of 2. Argument wz is just equal to the sum of their angles or arguments. So it's pi over 2 plus theta.